All right, so this has come up several times. People have asked for instructions on how to create something that's like this, like some sort of captive slot type toy where there's something that goes through a slot and it can move evenly back and forth. Sometimes that takes the form of like a stylus where it's not captive. And when I say captive, I mean you can't take it out like a captive, like a prisoner, sort of like the peg is a prisoner in the slot. So that's what we call it in like an engineering world, is you call that a captive part. It can't go anywhere. It's captive. If you are trying to make one of these slots and you don't want it to be captive, you just skip the part where I'm going to show how to make a peg. Okay, but I'm going to show how to make one of these, but I'm going to do it with a curve. Also, I'm going to explain some of the nuances of that. So look ahead for that. I do have a drawing done here to show a cut as if we have sliced it right across the little fish in this little diagram here. This is what it looks like when it's what we call exploded, which means taken apart. And so we've got this peg on the bottom, we've got the fish on the top. This is the underside of the fish. There's an opening for the peg to fit into. And we can see that here, that the peg, because this is all sliced open, the peg is going inside of the fish. And there's a tiny gap here so that it's like tight, so it sticks on there. About 0.254 of a gap on one side, which totals to about a half a millimeter, about 0.5 for the whole thing. And for the actual peg, we leave about a total of 1 millimeter, which means we do half of that on one side, and then the other half will appear on the other side. So when you add up 0.5 from here to here and 0.5 from here to here, you get about 1 millimeter total. So there's different ways to think about that and look at it, but that's where we're at. So I'm going to just do this. I'm going to try to go quickly. You can always slow down the video or rewatch parts, but I don't want it to be super long. So I'm going to just make a sketch. I'm not going to talk a lot about dimensions or sizing. I'm just going to kind of do these in the background, and I'm going to just use even round numbers. You will need to do the types of sizing that you want to be able to do to make this work. I'm going to extrude this. I'm not going to smooth out the edges or anything like that. I will leave that up to you as well. I have other videos on how to do a fillet to round the corners, stuff like that. So this is just going to be bare bones to show you how to create a slot. So for creating a slot, the easiest way to do it to make sure it comes out nice and even, if I make a sketch on top of this face here, and I'm going to click the top of this so that I can see. I'm also going to hide my planes. I'm going to hit P on the keyboard, and that's going to hide all those other planes to get them out of the way. To make, like, let's say a straight slot, I'll do both real quick. A straight slot, you might just do something where you draw a line, and you'd probably want to dimension the whole length of the line so that we know how far it is. Let's make it a nice even 70. I like to dimension things meticulously. We'll make this 15 millimeters away, and that looks pretty centered. Then we have the offset tool here, but if we click the drop down, there's a slot option, and this will create a slot around a curve, like a single curve. So if I click on this, we see it makes a 20 millimeter slot. In some situations, you might get an error here, but you can always make this smaller. Usually making it smaller makes it better. So, I did 0.5 millimeters. That's way too small. Let's do 5 millimeters. And that is the radius of this arc, which means it's 5 millimeters out one direction, 5 millimeters in the other, which means if we did in fact take, whoops, I didn't save it. If we did in fact take a measurement from one side to the other, let me just fix that quick. It should be about 10 millimeters. So I'm just going to click. Man, I keep losing it. I got to not be so quick to hit escape. Okay, ready? 5. Click to do the accept. There we go. Okay, so if I click on these two lines here, we see down in the corner, the parallel distance between them. Oh, I'm sorry. This is giving the diameter. So this is the distance from here to here. That's what I expected. It would have an R if it was a radius. I'm going too fast. I got to slow down. So anyways, this is the distance across here. So if we wanted it to be 10 millimeters from one side to the other, 10 millimeters is the parallel distance between those two lines. That's what we want. So anyways, then I could extrude this, right? I could do extrude. I'd pick the inside of that. I could do remove, and I could do through all, and it's going to go through everything, and that gives me a slot. Now, I promised a curvy slot, so let's just delete this here. I'm going to just delete that sketch altogether. I'm going to restart. So if I want a curvy slot, I'm going to make a sketch on top of this, just like I did before. And let me turn on my clicks. I should have turned them on before so you could see them. And now, instead of doing a line, I could do arcs, but I'm going to do a spline. And if you do arcs, you really need to make sure there's no like sharp corners, or else when you try to do the slot tool, it won't work right. And I'll show you what that means. I'll deliberately do one that's going to give us a problem. So if I make this really tight, if you think about it, I'll do at the end, I'll double click, there we go. If I try to do an offset at some point, think of like a worm. If you bend a worm too much, it starts to run into itself down at the bottom. And so if I do that here, if I do a slot and I pick this entire curve, it's giving me an error, because what's going to happen is when we get down here and it tries to do this tight corner, or the tight corner over here, it's going to be bumping into itself. And Onshape is like, I don't know how to do that. That's too much for me. You're confusing me. If we make this really small, it doesn't even work. So that's because the curve was too extreme. So I can fix that by smoothing this out and trying to make it a little less curvy. And you know what? Can I delete? There we go. I'll delete a spline point there. So this should make this a little smoother, and it's probably going to behave a little better now. Oh, and even there, see, I did the spline too tight, and it doesn't like it anymore. So splines can be their own little beast. You have to play with those. So be careful if you're using splines, because you have to understand how these points work. But I think that is smooth enough now that I think it's going to be cooperative. Let's try it. So I'm going to click slot. I'm going to click on the line. There we go. And so now a distance of 5 is working. But if I make this bigger, let's try 10. Now I get an error, right? Because it's probably this curve down here is like too curvy for me. So let's try smoothing that out a little bit. I'm going to try dragging this point, and it may fix itself. Oh, it's odd that I can't. Oh, it's stuck. Oh, for Pete's sake. I don't want you stuck on here anymore. Hey, there we go. All right, so it just rejected that slot altogether, but let's try again. There, now 10 works because I made it smoother. So that is kind of the idea there, is that you can change these slots around, and oh, okay, there we go. And that will move with the line, but you see if I put too much of a kink into it, right here, right at that elbow, the inside, see how it's crossing over? Onshape does not like that. It's going to give you an error. So I just wanted to illustrate that. So anyways, let's make this a tiny bit less extreme. Let's adjust this a little bit so that it's not going to run off the edges. All right. Oop, and I got it. It's too much of an elbow there, so we'll smooth it out. All right. This, if I extrude this through, is going to make, remove, there we go, through all. It's going to make a nice slot that I could then have something that moves inside of. So that is how you make the basic slot. Let me show you real quick now how I would create a peg or a pen or a cylinder that's going to go and be able to fit inside of this slot. So what I usually do is I make a sketch right on top of there. Okay, we're basically going to draw a circle, and then we're going to extrude it in 2 directions so that it sticks inside of there. And when you go to 3D print it, it will move it out of that hole. So that's how you'll be able to 3D print it. Okay, so I made the sketch on the top of this. I'm going to just draw a circle. I'm going to hover around until that outside arc lights up. And what I should get then is I can now hover, and I can get the center point of that arc. And I'm just going to click to make a distance in there that is inside of that arc. And then I'm just going to dimension the distance between the outside arc and the inside arc. And we only need a tiny bit of a gap here. If we do like 0.508 or even just 0.5 millimeters, that should be plenty of wiggle room for you to slide this cylinder through there. And now we have that created, that circle. And the last step is just to extrude it. So I'll extrude like normal, extrude, we'll click the circle. So this is where I said we have to go in 2 directions. You really could just make it go as long as you want up here. And as long as you know it's going to be long enough for what you need from this number, that's fine. Like we could do 60 millimeters up. If you want, instead, you could do like 30 millimeters up, or let's say 40 millimeters up, and then you could do a second end position, and it's now going in the opposite direction. And you see this number changes when I change this distance. So maybe I wanted to do 20 millimeters down, and that's going to give me a total length of 60 millimeters. You can also do symmetric and just pick the total length of 60 millimeters, and it goes evenly in both directions. So that's how symmetric works, 60. So there's a million ways you can do this. That's just one way. And now you have your cylinder that would move through here. Okay, so if this makes sense now, you could go play around if you think you understand what's going on. I'll show briefly how to add a cap to this now also. So to add a cap, okay, and this would be like I said, if we want to make this captive, okay, we're going to have to make it like a nail so that there's a head on one end and then a cap that's removable on the other, so we can take it apart and then when we 3D print it and then put it together after it's 3D printed. And that's actually how we did this fish over here. When we separated these two, the fish is the cap and this is the head on the peg on the bottom. So that's what we're going for here. So to make a peg, you could do, or to make the head on this, you could do it on the top or the bottom. I'm going to just make a sketch right on the end of the cylinder. And I'm just going to draw another circle just like before. Hover around until I get the center. Make it a little bigger. You want to make it at least bigger than the width of your slot. So let's just dimension this so that it's, I don't know, let's go with, well, I know the slot was 10 across, so let's just go like 15. So it'll be a little bigger than the slot. Check mark. Okay. And then I'm just going to extrude. I'm going to extrude that ring. And instead of going away from the object, I'm going to flip the direction. And I'm going to make sure I'm adding to the gray material. And it's turning red now because it's touching the blue material. But if I drag this down, let's just go an even 5 millimeters. That's going to add a nice peg onto the end of that. And it joined those two together. So you do have to pay attention to whether you're adding a new material, you're adding to an existing material, you're removing. We don't use the intersect too much. And the last step, of course, is to add that ring on the top here. And that's going to be very similar, except I'm going to make sure there's a little bit of a gap so that it can slide onto there, because if we make it the same size, it's not going to work. And I'm going to make sure it's a separate part. So I'm going to make a sketch on top, okay? And I'm going to draw a circle from the same center point. I'm going to do 2 circles. I'm making it like a ring, all right? So there's one, there's the other, and then I'm going to dimension them after. So this distance, this time we want it to be tight, the distance between the outside circle and the inside circle. I'm going to do 0.124, right? No, 0.127 is what I want about. If you're off a little, it's okay. So 0.127, that's going to be our first ring, and that's going to leave about a total of 0.125 for the gap so we can force it on there. It'll slide on, it'll be tight. And then we've also got to set the size of this. I'm going to drag this circle a little bigger. Again, it shrunk down on me. And I'll set the distance between these two. And let's make this is just like all the other circles. If I do 2.5, it's going to do a total size bigger of about 5 millimeters, because it's 0.25 on this side, 0.25 on that side. Click the check mark. Then I'm just going to extrude the ring. And this time I'm still gonna go down, but I'm definitely want it to be new. So it should be a different color, just like this. Let's do 5 millimeters again. And that's gonna give me a ring that I can slip on the end of this. So when I 3D print it, I have the base, I have a peg with a head that can't go out on the bottom, and then I have a ring that slides over the top that allows me to assemble this at the end. I could drop a little glue in there or something, super glue or something else to keep it all from coming apart. The last little bonus here is if you really did want to make, like, say, a fish design or something, you could create a sketch on top of the ring, okay? And you could do something like this. Like, let's say I want to make a smiley face because it's really simple. I'm going to make a circle that's bigger than the ring. Let's set the size of that one. The ring was like, we could even do the difference between these two again. Let's make it 5 millimeters bigger on one side, so it's really 10 millimeters bigger total. Oh, we'll just do 5. Okay. And then I'm going to extrude that to create for myself like a flat platform. But watch this. When I extrude, I have to be careful what I'm picking. I have to pick this. I have to pick this. I have to make sure I'm picking all of the circles so that I get a solid shape on top, and I do not need it to be so thick. We could go like 3 millimeters. And the last thing is, again, this is a different color. We want these two to be linked. We want them to be like glued together. So I'm going to say add, and it wants me to tell it, do I want it to be added to the gray part or the blue part? That's what the merge scope is. And I'm going to say I want to add it to the blue part by clicking on that, and it's going to merge it with that. And now I have a separate little piece here, so that blue part is its own piece. And that is going to allow me now, I could make a design on top of this with some eyes and, I don't know, a mouth. I could even use that slot idea on the mouth again. Maybe I want to go like this. I don't want it to be frowning. Let's make it happy. Let's make a little slot around that. We'll make it super small, like 1 millimeter. Okay, check mark, and then I could do an extrusion of just those little shapes, just up a tiny little bit to give me a design, so like 1 millimeter. Ta-da! And there's our smiley cap on there. And so this would stay inside that slot. It's not going to go anywhere. And this is how you create a peg in a slot, and so the peg can't come out of there. So hope this helps some people.